Welcome to the presentation on Modernizing for the Future. I'm Scott Pickett, and I'm happy to present this content to you. I've got over 35 years experience in the industry. I've worked on transformation projects for the last 4 years. I've worked in private, public, and startup companies, and started out in semiconductors and developing software tooling. Worked on embedded systems and large enterprise software deployments that are currently in operation across the country, and have done a number of cloud deployments. Over the last 4 years, I've worked at TSRI and have modernized 20 projects during that time period. I hold some 25 patents and have been a member of a couple different standards committees. While at TSRI, I've been focused on modernization. TSRI is all about software modernization. It's developed a Janus tool set that allows for automated transformation, supporting a number of different gateway technologies, over 35 different programming languages, in fact. The company's done over 200 automated modernization projects, and they've all been successful. It's a fully automated process. It has a documentation service as well, and it allows for an automated refactoring phase, which is quite unique. The solution allows for legacy code to be put into an independent object model, and at that point, it can be refactored. You can go up and down the abstract syntax tree and do different types of refactoring for not only code quality, but performance. And actually, that can be customized for a given project as well as for a given language. The company has headquarters in Kirkland, Washington, and presence throughout the world, including in India, and design centers in Phoenix and also in Washington, D.C. There have been a number of different successful projects delivered, and these are referenceable accounts. As I'd mentioned, I've been involved in about 20 of these projects. Large institutions, major retailers, manufacturers of aircraft, very, very, very large companies, millions of lines of code. And this is done through a pretty regimented process, customized tooling in some cases, supporting a number of different type of gateway technologies and target platforms. Today, I'll be focusing on software modernization for the cloud, and talk about the scoping process, the planning process, how Agile applies, what's required to execute on these projects, what is done in test and why that's different, touch on the concept of continuous modernization, and then reflect back on the lessons learned and some of the pitfalls and some of the things that you can do to avoid those pitfalls. First, the scope. Possibly the biggest obstacle at the beginning of a project is really identifying what's in scope. Sometimes this is as simple as not having the complete tool set, not having the complete, not tool set, but the complete code, not having all the copybooks, not having all the code, having some of the files not there. The planning process requires a solid baseline. It turns out TSRI is able to mitigate that by being able to have automation. So we can accept changes in new code pretty much at any point in the process because it's an automated process. But it still means that you have to go through and revalidate, re-verify, retransform, and then go through the whole process again. So having a solid baseline is critical. And changes in that baseline often means there could be additional services that are required, additional externals that are required. So it's really important to have a complete legacy code set. The other thing you need is a target as far as what the target environment is. So you need to go through and set exactly what coding standards you want to have, what environment you're going to be able to support, what tech stack's going to be supported in that environment, what services that you want to leverage in the cloud environment. All these need to be understood. Again, this is best addressed through a collaborative workshop or a series of collaborative workshop, multi-day workshops, where you sit down with developers and leads and product owners and the customer side and be able to understand exactly what they want to have, what's important to them, whether or not maintainability and code quality and code standards is going to be critical, whether or not, additional test cases is an asset that you want to build as a part of the transformation. So understanding these target points is critical up front. And it also allows you to be able to be successful as you migrate through the overall transformation process. Another key component is the management and governance. And this is really project dependent. Some large institutions require a governance council. Some developers, some companies that you work with require to have code reviews and detailed technical review. Some of these projects need to demand that metrics are available on an ongoing basis with dashboards that'll let you know exactly how many bugs there are, how many errors there are in the compiler, what tasks are being done, who's doing them, how long it's taking, reports on a regular basis, and burn down charts that allow you to see exactly the velocity of each team. Another big part of the overall management and governance is the validation phase. Validation of code, validation of the data sets, validation of the new environments, validation of the code operating with the new data sets in that new environment. So those are all key components to the management and governance, which is required in almost every project. Another part of the project is being able to adapt to Agile. And TSRI generally uses a Kanban approach because things come in from the customer and from the code almost at any point in time, and we need to be able to apply resources immediately. So we basically use a Kanban approach, but then we adapt to be able to go in with sprints. And we'll talk a little bit about that. So it is a part of the release planning, and we do formal sprint planning, but we are very Kanban-esque with respect to being able to adapt to incoming issues literally in the morning and executing on them continuously. One of the big parts that's unique about a modernization process that takes advantage of a tooling like TSRI has with Janus is the ability to accept changes at any point. Once those rules for the transformation for a given gateway are written, they can be applied to any new code that comes in. So we can get changes, we can get updates, that are in operation, be able to migrate those through and redeploy. So all those are of ability for us to be able to kind of manage change throughout a transformation process. Another key point is, and I'll talk about again and again, is how critical it is to have these environments set up and available when they're needed. So I always push for getting these sandboxes and getting the target solution stood up before we deliver the code, and not be in a situation where you've got the code and you can only run it in IDE. You want to be able to stand it up in the cloud environment, deploy it, work through the software pipeline issues, and be able to make sure that there isn't going to be any infrastructure blocking you with respect to the code rules. And another big part of the overall process is being able to kind of understand and communicate the metrics, communicate changes, because you're going to have to expect some variance, being able to adapt to those changes and be able to understand when things can be done sooner and having the resources that can take advantage of them, and then when things end up happening later and being able to come up with contingency plans. So about that planning process, we typically kick off a project with a real strong understanding of the transformation itself. Whether or not the code is parsing, lexing, it's clean, and we can handle it. Then identifying what components aren't available with respect to externals, or with respect to calls out to other mainframe programs, or with respect to system calls and utilities that aren't available in the sources. And then developing a strategy that goes through and looks at the target architecture, whether or not which cloud you're going to be going to, whether or not you want to have a private instance of that implementation. Obviously, the target language, versioning, and coding standards. Big part of it's also data migration we'll touch on. and then going into the specifics associated with the, not just the syntax and semantics, but the ways that we can go through and transform and take advantage of the native types within the target language. Another big part of the overall planning process is the release and what's going to be done with respect to validating the solution. TSRI has worked with companies that have used an agile approach that's enterprise-wide, that leverages multiple different teams operating in parallel. So you have one team focused on the infrastructure, another team focused on the database migration, another team focused on the transformation, another team focused on the framework elements, another team focused on the cloud services, all operating in parallel, having a number of different dependencies and being able to make sure those dependencies are unblocked when the other team requires them, and synchronizing the spirals and making sure that those spirals, which are deliverables associated with the code, are growing in content and offered at a time that's required to fit into that sprint planning. So all these are critical components that are happening at the beginning of the phase, and oftentimes they're set and they're set in stone, and you work through, chisel out the areas that need to fix as you go through the project, and you accommodate in order to meet the objectives with respect to the time frame and the budget. One of the tools that turns out to be pretty critical in actually going through the modernization of the code is what TSRI offers in software blueprinting. And we have an online services also for this to be able to evaluate application blueprints in DocsRev. And this shows an actual transformation blueprint. So you actually see at the top left-hand side or right-hand side, both the COBOL implementation and a Java implementation, the same exact piece of code and a graphical representation of that, so that the user can actually see, or the main person who's maintaining the solution can actually see what it looked like before in the legacy language, what it's going to look like in Java, and be able to literally hot link and go between the two. A big part of the planning process will look at these externals. And these externals are basically anything in the code that's called that we don't have the code for. So these can be diagnostics or data management or sort functions or sync sort functions that literally were in the mainframe environment or in the legacy environment, but they're not available in the modernized environment. So what do? You have to go through and develop a replacement strategy for those. And we'll talk a little bit about that in a later slide. Architecture planning with respect to the cloud is obviously critical. And a couple of major points. There seems to be a pretty big desire to try to maintain some level of cloud independence, especially when you're going to a Java solution. So that is a consideration to look at. If you begin to move from kind of a standard LAMP instance, kind of a Linux Apache type of instance, to a cloud native deployment instance, you begin to become a little bit more locked into that specific cloud service vendor. If you stay with a standard LAMP instance, and if you start to leverage native services in the cloud, but have them be somewhat standard-based, you're then able to migrate over to an alternative vendor if you want. There's generally two separate cloud vendors that are really dominating these transformations. From a language standpoint, either C# or Java. And there's generally 3 different target environments, whether it's more of an OpenShift type of approach, Azure or AWS. TSRI is deployed into all 3 of these and has deployed lots of code, lots of projects into these cloud-based environments. One of the big things that needs to be accommodated for early on is being able to stand up an environment so you can actually go through and do deployments early on. TSRI has been known to be able to do initial deployments literally in weeks to days and have code that's ready. And oftentimes the bottleneck will be, can we even get a sandbox to actually have developers start to do the integration with the services in that time frame? So you typically need to be able to be nimble with respect to the early phases and setting up a development and integration sandbox. Typically, the test sandbox will come a little bit later, or the test environment will come later. Often, customers will require a formal acceptance environment. You need to be able to consider also load and performance requirements in either a pre-production or a production-like shadow environment. The reason being is because the production data, oftentimes you cannot look into or have access to that production data when you're a modernization company, but you need to be able to have that production data to be able to do load testing and to be able to do performance testing. So you'll end up having to set up either a separate environment for that data, or have that data scrubbed, cleansed, or have test data that replicates the production data, at least from a size standpoint, so you can ensure that the solution is performant prior to going to pre-prod trial. And then what's oftentimes the case is being able to have automated deployment scripts to be able to push from the software pipeline into multiple different environments, depending on the quality gates that are required. Just to step back a little bit with respect to the process, you can start these projects and almost immediately have hundreds and hundreds of backlog items that are known, that you know that you have to do, and that can be pre-scheduled and worked on. So that's actually a benefit. You literally, because you're using automated technology, because we have a clear understanding of the code base, we have libraries and framework, we know what the externals are, we understand what environments need to be set up. You can actually plan for early deliverables with lots of different content. You can also plan for regularly scheduled interval deployments that are aligned with spirals, and those spirals are aligned with sprints. And those sprints can, again, happen early and often. Typically, we support sprints every 2 weeks and major deliverables within at least 1 month. Sometimes to get everybody, meaning the integrator, the customer, our team, to get everybody in sync, it takes a formal POC. And though that POC might be 500,000 lines of code, and it will go all the way through the process into actual deployment and validation and testing. And we have been in situations where we've done partial go lives with those POCs. And that gets everybody confident that this actually does work like a machine in being able to generate very, very, very stable code regularly that you can kind of depend on regular intervals. Again, with respect to the environments, you can plan for it and plan for it ahead of time and plan for it in sprints, but it always seems to be a little bit more Kanban-esque. There always seems to be, when it comes to environment, a need for more, a need for some level different type of services. Sometimes it's one of the blocking items. In fact, there are almost always some cases where there are blocking items associated with having these environments stood up. I think one of the basic points with respect to the migration to the cloud is get it out of the monolithic application environment, the stovepipe or environment, the mainframe environment, and put it into a service-oriented structure. That allows for a tiered layering of the data, business, and presentation tier that makes it readily available for the next step, which is being able to take advantage of cloud services, in fact, sometimes native cloud services and available cloud services, containerization that allows for what you're expecting with respect to cloud-ready solution. So that's the 1, 2, 3s, is initially kind of migrate the language, inject the entry points for the APIs to support a service level architecture, whether that's at the DAO layer or at the REST layer, and then being able to fully migrate it over to the containerized native supported cloud environment. One of the benefits associated with using an automated technology is that none of that is done by hand. And because of that, you're almost guaranteed not to lose any functionality. So there isn't any injecting in of new logic, there isn't any replacement of logic, and there isn't any taking away of logic. So since the model itself is a representation of the legacy source, and the target source is generated from the model, you're guaranteed the business logic doesn't change. So it literally should operate the same way, even though you've gone through this modernization process, putting in the multi-tiering and allowing for the ability to be deployed in a container that can scale out in a couple of different areas. The one other benefit associated with this approach is there's no real hard requirement to freeze the business. Oftentimes, not even with big bang solution, with any type of modernization solution, people have got to stop and do a hard switchover. And they're not allowed to take some of the new fixes that they have in production and just roll them into the new solution, because you end up having, hand refactoring and issues and having to go through regression. With an automated approach that you've been able to run on a project multiple times, literally sometimes hundreds of times throughout the project, there's no freeze. You can get inputs from production that are operating and make them available to the modernized solution that you're going to go to production at any point in time. In fact, we've done it after we've gone to production. We've accepted inputs and changes on the baseline source after we've gone to production. And the reason why is you're able to kind of continuously modernize that solution because it's 100% automated or 99.99% automated. So when you tie the emissions to the tooling, to code quality standards, to these quality gates, including unit testing, having complete regression testing, you're then enabling the overall solution not only to go through a software development pipeline and have a continuous deployment and continuous integration phase, but you're able to do a continuous modernization of the solution on an ongoing basis. This is all enabled through a series of APIs that are standardized and supported, throughout the industry. Typically, it's REST and our DAO. But we also provide a whole suite of libraries that handle all the data type differences between the legacy and the future, and mitigate any manual manipulation, because those libraries have been deployed hundreds and hundreds of times. So we were able to offer these libraries in source code form and allow you to go through and reintegrate and rebuild and develop and move forward with those with a maintainable type of solution. So one way to look at it is you had those, and graphically, you had those old ad hoc architectures, the mainframe architectures. And inside there'd be CICS interfaces talking to online programs, and those online programs would be making calls into a database, but it's all structured towards, kind of the inventory management. Or there'd be a credit manager type of application where everything was integrated into the same solution. The effective approach that TSRI takes is to put that into the same approach that has been done kind of by the industry, where it goes into a layered architecture, and then you go into a service-oriented architecture. When you get to the service-oriented architecture, yes, you have your data tier, your business logic tier, your presentation tier, but now you have that common infrastructure, and you can scale parts of that infrastructure up in order to be faster for, the database for the classic example. And you can scale out to support additional users. And you can also scale out to support additional business logic requirements. And then the final phase is that cloud architecture, where we're actually able to tie back into those legacy database interfaces, and we're able to tie forward into future application interfaces and presentation interfaces, all with the same basic core structure that is doing the same functional and business logic that was available in the old ad hoc solution. So you literally have the same functionality as your old green screens, the same functionality and reports that you had in your old batch programs, now operating in parallel, scalable, in a modern cloud environment, and being able to actually tie back to the legacy environment for other applications and databases, because you may not have integrated the whole solution and all the applications at one time. Possibly the biggest hump that people have to get over with respect to modernization is the testing paradigm. And the biggest part of that is that you do not have to test at the same level, the same way that you do when you're going through and doing regular development. You don't need to allocate the 30 to 40% of your resources and develop hundreds or thousands of test cases, because you have something, a huge asset at your disposal already, an operational system that's been operating for years, that's completely functional. True that if there's a bug in the old legacy solution, it's going to be transformed and it'll be faithfully implemented in the new solution. But if it is operating completely, all you must do is to do comparative tests to validate that it's proven. It's a proven equivalence. So you prove that it's the same. So you can do this through an automated comparison by having all the baseline that's been conducted in the previous legacy solution available in the modernized solution, run those same baseline tests, and then compare the results. You're not required to go through and develop those from scratch. You don't really even need a detailed test SME to develop the test cases. What you need to be able to do is run the tests in the legacy, extract out the data, the input files, you have the output files, migrate them over to the new environment, and then validate to see if there weren't any changes. After that, you can go through and build out additional test cases to give you additional coverage. But you're able to gain confidence and momentum as you move forward, proving out, yes, there's been no change in the business logic. Yes, it operates the same way. You're getting the same display feedback. You're getting the same reports, and you'll gain more and more confidence over the course of operating these comparative tests and just comparing the results. That's the big change. Any of the automated tests will run the same way. You don't have to rewrite automated tests. All the reports that you were getting previously, you'd be able to compare to the same way. Because you've eliminated all the human issues associated with modernization, all the specification issues, it's all machine generated at that point. So you should not expect any differences, and all the usage cases are the same. So the people that are working on it previously should be able to work on it the same way and not require any new knowledge in order to operate it. So black box testing is most appropriate, and often there is no other requirement to prove equivalence. The big part, though, is to make sure that you get that baseline. You have to have the code baseline in sync with the data, run the tests, so the code, the data are synced, do the transformation of both those, and then compare them. If your database is not in sync with the baseline, you go through the process, there's chances there's going to be a discrepancy, and your validation is going to fail. So you really need to make sure that you've got your tables, your input files, your code, make sure that all of that is transferred over with a complete data set with the same code baseline, and then you actually do the testing in the modernized environment, and you'll see the results are the same. The reason why? Because there's no change in the business logic. There should be no change in the test results. But there's a couple of other things that TSRI does in order to assist this process. One is just injecting in telemetry. Telemetry is a simple statement. I've got highlighted there is that logging enabled statement for that one program. And it basically goes through and inserts a little bit of instrumentation, a logging element within the source of the legacy in COBOL. You run the tests there, you get a log file. Now, when you do the transformation, you have the same exact statements in Java or C#, and you're able to generate the same logging, and you can compare the logs. Now you know when you run those tests, the exact execution path for every paragraph in the COBOL, every method in the target, and you're able to say, oh, yep, they line up completely. This is the same code path. That will also give you visibility into the coverage of those tests. And you can then put in negative test cases and increase your coverage without, kind of the functional duress that you might be under and not knowing, how much you have covered, how many more cases that you need to support. Possibly one of the other efforts that happens, I wouldn't say for every transformation project, but it's becoming more and more prevalent, is to be able to do an API level test. Whether or not that's using something like, JMeter type of test, or whether or not it's a proprietary API testing. But the basic concept is capture the live environment today. Capture the interfaces that you have today, record them, store them, and then play them back in the modernized environment. And it should operate the exact same way. Oftentimes, we actually extract out the API calls out of a dump. In one case, for a government, they turned on all logging for all the citizens of this one country for the login, captured all of the APIs for that login for the weekend. We were able to then run those APIs, those same exact APIs pairs, on the modernized environment and confirm that it was going to work the same way. And true enough, we did not see an issue with that when we went live. So you actually capture it in a live environment, or capture it in the existing production environment, migrate it over to the modernized environment, run it the same way, get the same results. So those are some examples that are quite a bit different than, if you're going to go through a rewrite or with other type of modernization methodologies. So back to these targets and what it looks like in the cloud environment. This is a real basic example of what happens when you take an online Kix mainframe type of solution that's leveraging DB2 and you migrate it into an AWS Azure environment. The COBOL programs go over to Java. The DB2 goes to RDS. You end up in a situation where that's pretty much all of the automated transformation for the back end. On the front end, you have to go through and do the screen transformations, where you take these BMS files and you map them into a screen model that then is supported in a MVC type of an architecture and rendered similarly. Those screens now, instead of talking through Kix on the mainframe, are now talking through a REST interface that hit our TSRI's Kix library, and then be able to call upon the online programs. There are obviously APIs and DAOs and flat file interfaces as well on the other side that allow for the online programs to be able to dip down into the database, and all that support is done through those libraries. But that's a general mapping of what the legacy is in green and what the modernized environment is, in this case in the AWS environment. Similarly, for batch programs, this little example is Azure. Here you see that Azure has a Azure scheduler that can be a Computer Associates scheduler. It could be a Tivoli scheduler. It could be any of those schedulers. Most schedulers are already having offers that run in the cloud, but you can also use a native cloud scheduler like Azure Logix, and it will kick off what was the JCL, which is now Python, and that Python script will go through and invoke a batch service that'll be done through a REST interface. And if it's an async module, it can run kind of an indeterminate amount of time. So there turns out to be a status manager that will ensure things are kind of completed, and then go back to the Python script to be able to make sure that it's complete. And the synchronous mode is much more straightforward with respect to each batch job passing back through this HTTP and JSON interface to the script to be able to close out. So these typically also touch other services, whether they're FTP services or mail services, messaging services, file services, and you just hook into those through kind of standard interfaces that are available in the cloud, and we've developed framework to be able to support that. And kind of looking at this from a AWS standpoint, I'm just going to kind of talk from left to right. One of the first things that people do when they modernize is they relook at some of the access management and modernize the access management. So, we'll kind of, put together a facade that'll allow this to run without that being done, and then integrate in as required. And you typically would integrate into like Cognito, identity and access management solutions from AWS, and that would touch on the directory services, and that directory services could actually be LDAP based or be AWS based. It could even be Active Directory based, and that would be kind of a service native on the cloud environment that would tie into the services that are required to be rendered to the end user. This can all be done in addition to kind of the RACF authentication that's available in the legacy, which can be continued to maintain. So you can still have table-based authentication for those users implemented in the logic that's still maintained. So you actually get an additional level of authentication, security, and access management by leveraging both. One of the other major points associated with this diagram is the ability to scale out on the presentation layer. And not degrade in performance. I'll talk a little bit about that later, but in short, something like Redis allows for the ability to have the browser and stuff close to the end user cached in, and still being able to support a distributed database for multiple different program sessions that are required to be able to support the cloud-based storage and database. So Redis has been extremely effective in dramatically reducing the round trip delays associated with end users expecting a response from a single screen, and literally being able to pull the data that's required without having to do deep data dips for every single element that you might be toggling on. A couple of other major components here are the API gateway and the storage gateway. One of the benefits that we've seen with respect to cloud modernization is that it's not an all or nothing type of a solution. You can maintain the ability to support legacy databases. You can support the existing mainframe database. That can be done through an AWS gateway. It can be done through a separate DAO mechanism. It can also, on the API side, you can interface with other applications that are available on the mainframe through an API gateway, and you can resolve those externals through an API gateway. So in these cases, there's going to be performance impacts, and there's going to be the ability to actually go through and do the profiling to make sure they'll perform. But functionally, you can actually migrate core parts of the technology and still be able to interface with peripheral technologies, or you could migrate peripheral technology and be able to interface with legacy core technology through these gateway mechanisms. Everything can scale out with respect to the presentation layer through standard application load balancing. I'll talk a little bit more about that on the batch side. Container registration is normal, can also be under orchestration through Kubernetes. All of it can be managed through AWS CloudWatch and standard type of management and reporting solutions, and those third-party type of offers with respect to performance management and security management can also be applied. On the batch side, I think the big thing here is that you're able to also support the replacement of some of the legacy solutions, whether they be queuing services or API solutions, with native AWS services. So AWS, simple queuing service can now replace what was previously the Ibm Mq service. You can interface to all the file mechanism, not just file systems, but FTP and secure FTP, and often those are unique for mainframes as well. Your mail services, whether it's IMAP or POP3 or messaging services, SMTP, all those are available and can be easily kind of integrated and plumbed in to the AWS environment. I mentioned a little bit about the scheduler. Same type of opportunity exists with AWS Simple Workflow Scheduler. So you can replace the scheduler mechanisms for either an async or sync mode job and associated batch program. And then again, you're able to go through and migrate the data over to a standard RDS or Postgres type of implementation, and you can still go through and tie back to that legacy. And that turns out to be critically important for these modernization solutions where people are extremely sensitive to risk and conservative with respect to institutions being able to have citizens and banks and insurance companies very, very, very cautious with respect to these deployments, and it allows you to be able to leverage the legacy and fall back without any degradation or impact to the solution. Another key component with respect to modernization is about the database migration. There's three basic components to this. First component is to basically move the schema over. Big note here is you don't want to do normalization. You don't want to be doing normalizing the database and doing really, really heavy refactoring on the database when you're doing data migration of the code. Because it basically is a situation where you want the DDL, you want the schema to basically represent the older schema. If it doesn't, then you're going to have to change the code. And again, we're primarily focused on not changing code, not changing the business logic, so that you do not want to change the schema. So we basically emulate the legacy schema in a modernized database, and that ensures that you can kind of bring the solution forward and guaranteeing the business logic will remain unchanged. Couple real interesting points though is that you're able to support multiple DAOs. What this allows you to do is be able to have a data store that's still on the legacy solution, and then have a new database on the new solution, and be able to point one or the other. And you can do that on a table by table basis through configuration, which is another unique thing that you're able to do in a modernized environment. That's not necessarily the case in the legacy environment. And you're actually able to do that based on what the actual application is. So if there's only part of the application they're going to go live with, you use only the databases required for that application, and then be able to sync it through third-party synchronization tools that are offered by Microsoft and Oracle and AWS and IBM. So you can do data syncing tools between the two, and that kind of happens in the background. The next phase of the data migration is to be able to support the actual ETL script. And that's where you're kind of doing the extract. There's an IBM tool that's typically used for unloading it. And then you can use either TSRI's tool, or we've used third parties as well, to be able to go through and do the actual physical migration into the new SQL RDS database. And then the last part of it, which turns out to be done multiple times, this process is conducted multiple times, I can't emphasize that enough, before you go to a production type of a migration, is that you'll do a complete round tripping. And we've done that based on common file format extracts from both databases and doing a comparison, and then ensuring that that comparison is correct. And then also being able to be in a position where you're also able to compare table by table. And then obviously when you do the testing, it requires the valid database. So there's actually a three-phase part to that data proven equivalence. There's three more things I want to touch on with respect to cloud-based migration and that are real important. One is a concept on partial go live that allows for the front end to partially be able to be tested and validated in the live environment. In this case, you could have both specific users, like a friends and family, 50 or 500 users, be able to address the solution. So you do that through an access layer. In another case, there have been endpoints turned on to allow for specific REST calls to be able to go to the back end. And this dramatically reduces the amount of risk, because now you're only having to go through and implement, let's say out of 400 different APIs, there's like 50, and you'll do a trial on 50. And you do that for an extended period of time, and you get pretty confident that, yeah, this REST interface and the new modernized solution is doing the same thing as the legacy. So let's go through and do another batch. So you're able to do it based on user access. You're able to do it based on the actual screens. Similarly, as I just discussed previously, you have the ability to support different databases. Done this on multiple different projects, very large projects. One of them was for an entire country. The other one was for the largest bank in Europe. And it basically allows for the ability to have a reach back capability into the legacy DB2 database. And then you have that database in sync with the modernized database. And this provides a mechanism to guarantee that not only is there going to be a fallback mechanism in the future, but you actually have a live fallback mechanism with two different data stores, and you're proving out the business logic independent of the data. So you know the business logic is the same because it's working with the old legacy database. You know it's going to be the same because you're synchronizing it with the new database. And when you migrate them both over the new database, you're much more confident that the end-to-end solution and the data associated with it are in sync and work. So and all this requires additional configuration. One of the benefits with cloud technologies is these deployments can be done quickly, and they're done automatically through scripting capability. And in these cases, both of them were both public, and then they migrated to a public hybrid cloud. One of the other things that you can do with respect to these services is you can actually put some of the services in a new environment under control of the legacy environment. And one of the cases that we did was with respect to IBM Mq. Now, in this case, the queues were extensive. There were thousands of different queues, literally. And they were concerned that we're going to move everything over to a new cloud instance and having problems. The way we mitigated that is by instead having the queues remotely register with the IBM controller. So you end up having kind of cloud-based agents in these cloud instances under control of the mainframe solution, or the mainframe MQ manager. And that just mitigated that whole issue because now you didn't have to go through and move the queue manager and the agent at the same time. And then eventually you switch it over and have the entire queue manager, and you've mitigated the risk associated with that, knowing that the queues were operating the same way on the modernized environment as they had in the legacy environment. A similar approach was taken with an enterprise bus, where what you ended up doing was being able to define a whole new series of interfaces through an enterprise bus that was operational in the cloud environment, and it replaced some of the APIs and interfaces in the mainframe, and then they were able to cut everything over to that enterprise interface for all the externals and interoperability between mainframe communications. So in summary, there's a couple of major points that we want to kind of bring out again when you're migrating to the cloud. One, baseline understanding, baseline testing, extremely important. It will bite you. So having an automated technology that allows you to accommodate is critical. But as much as you can do to find out what's inactive, what's going to be obsoleted, what can be what is replicated and duplicated, and what's unique upfront, the better. Identifying externals and what type of dependency you have on the actual mainframe and legacy system. Do you really need to do the same type of disk management in the new environment? Do you need to have the same type of management operations in the new environment? A lot of those system level functions that are in the mainframe aren't applicable. So you need to go through and scrub those out. Some of those things are available for free. Other services can be more expensive. The point is that you can embrace those cloud services when they're available and turn them on as required. Another big point is on performance. The bottom line is that the mainframes were really, really efficient at doing some inefficient things. You can go through and have screens cycle through very deep data dips for just the next record. And that doesn't make sense when you move to a cloud technology where you've got a separate presentation tier from a business tier and an application tier, all going through independent protocol stacks through switches and routers. It turns out to be, six of those on each side. And that's before you get into any of the load balancing type of solutions that are out there. So it can be very, very inefficient to do that. So you need to look at being able to say, well, it makes sense to use caching technology and bring that content closer to the presentation layer. Distributed caching technology, whether it's Redis or Hazelcast, either one can apply in those solutions. Sometimes you'll look at scaling up. So instead of solving solutions scaling out, you scale up the database layer so that that is more performant. In other cases, you got to look at the logic and say this needs some additional refactoring. And TSRI has kind of developed technology that looks at kind of deep nesting and do pattern recognition on that for replacing it, and allows for kind of automated refactoring in just those cases. Another area that's real important there is doing the application profile management solution. Those APM solutions can identify, where the real problem is. Is it at the data tier? Is it in the network infrastructure? Is it on the business server? Is it on the presentation server? And once you know if it's in the software, which isn't always the case, but it can be, then you can go through and provide profiling tools, find the hotspots, identify those hotspots, prioritize on which ones need to be done, do the refactoring, do a new baseline, and see if there's an improvement. So all those are the type of tools that are needed in order to make sure that the solution is going to be performant or even faster. And then the other major point is the big bang approach is really full of risk. And a graceful migration is oftentimes a way where you can go through and take that step gracefully. It can actually coexist. We've been in situations where they've done a graceful migration for a year, in entire, very large business units and entire populations being able to use both legacy mainframes and a modernized solution and vice versa over an extended period of time, just to ensure that there is no outage or issue. You can support failover back to the mainframe and know that you're, kind of solid, and you can take it one feature, one function, one API at a time, one database table at a time, or an entire application and a region. So in short, TSRI is dedicated to this area. We are seeing well over 50% of our solutions targeting the cloud now. It seems to be this year, all of our solutions are targeting the cloud. We're quite excited to be able to support these migrations. We've got the tools and the people to do it. And I appreciate everyone's time, and hoping we can address some questions if they're available. Thank you. So there's a question on how will you know which languages systems should target. Well, I don't know if there's much debate, but the best answer there is probably the most popular, and the ones that are most popular as far as these target languages right now from a backend standpoint are Java and C#. I don't know the details of it, but certainly vast majority of our transformations are migrating to Java and C#. How might an environment not be ready? There's cases where the environment just hasn't been signed off on from a IT or a security standpoint, from an onboarding standpoint, people can't get access to it. So there's 3 or 4 different roadblocks that can happen outside of the technology. Generally speaking, the technology does not hold up the environment. It's the process, the people, the structure, and the security that generally holds up the environment. Sometimes it is a funding part where they didn't apply funding or weren't aware of the funding. But for the most cases, the environments are not really the technology hold up. They're more of a people hold up. How do I protect against running into that kind of obstacle? I think getting early sign off on the environment, getting all the security onboarding and whatever needs to happen in order for people to get access to the environment set up. And then the big thing is setting up prototype sandboxes. Have your developers just put something together where they can deploy code into without having it, even official. Just have them able to work with the environment and understand that, deploying a container and opening a VM and even having a developer have a VM with IDE debugging in that environment, those are all positives in the solution. And as soon as you enable that, the more likely you will to have a successful project that it deploys into production environment. Cloud versus on-prem. What are considerations in making my decision of where to migrate? There's cost points there. There's that cost. You can kind of manipulate the model either way, but generally speaking, the upfront cost for on-prem solution is going to be substantial. The ongoing maintenance for on-prem solution is going to be substantial. So if you don't have that money and you don't have those resources, you want to go to the cloud. Being able to support a hybrid model is not always the best of both worlds. It is from a kind of a reliability and a flexibility standpoint, but it can be even more costly and be more rich in resource requirements than just being an on-prem solution. And then on the cloud solution, it really is going to depend on how deep you dive into those native services and how much visibility and experience you have on which of those services are going to be expensive for you as you do your transactions and run your business. So that's going to require some additional analysis. But certainly from an upfront cost standpoint and from an ongoing maintenance standpoint, that those are 2 big pluses for cloud environments. So the concept behind a spiral, a spiral is just a regular delivery that incrementally grows and builds on each other for each iteration. So you start out small and you spiral out, you gain more content, you become more and more code. The next sprint, you do another spiral, capturing more content, more applications, more code. And these are usually hundreds of thousands of lines or 500,000 line spirals that'll go to 1 million line spiral. So it's substantially more code. And you want to do that. So you're building and building, not just on the code functionality standpoint, but also being able to test, validate, and deploy. So the spirals are an incrementally increasing amount of functionality in code, typically aligned to sprints. Looking for other questions. What's the performance of the modernization application compared to the legacy? We've generally seen that most of the online applications can be within the requirements. Now, obviously, if you've ever been in front of a mainframe, that screen flashes back instantly. And when you open up your browser, it usually takes a second to a second and 1.3 seconds. So there is a difference. But when you look at being able to, for a workflow that uses those screens and a workflow that uses a browser to replace those screens, they are acceptable. And we've gotten every single one of our online programs to be able to cache in, provide content that is able to enable the workflow within the requirements. On the batch side, there typically are some batch programs that if they run at night and they get done by the certain time that's required for the scheduler, it isn't an issue. So there may be 500 batch programs and there are 40 of them that are kind of close to the window. And then you need to look at them and see if you can run those in parallel or run those on a dedicated server in parallel if there's no dependencies on other batch programs. And then of those, there might be one or two that require you to actually go through and look at, and you find out, sure enough, if you did a batch request on all the data at once, instead of this incremental request, it would be much faster. And so you do some level of refactoring. Some of that refactoring can be automated, and then because it's pattern-based, and then you're able to resolve the problem. Well, we've generally in every case that I've been involved, been able to resolve all the performance issues, and usually performance issues are limited to those deep data dips that are, they're done inefficiently well on a mainframe, and when you put them in a distributed environment, they're exasperated, and you've got to apply technology and solutions to resolve them, but that could be done within scope and on time. Any other questions? The biggest difference between a software modernization solution that I've described here and a lift and shift is ownership. When you do a lift and shift, you're basically running that solution in a proprietary environment dependent on a proprietary solution that's basically running in a public cloud or a cloud technology. TSRI is providing the code. It provides source code and it provides libraries, and those libraries allow you to add on and change them. You own that solution. You could pick that solution up and you could put it on an OpenShift solution in your own environment on your own. You can't do that with a lift and shift. A lift and shift, it's already kind of the environment is theirs. It is the vendors. So it's a fundamental difference. If you want to own your code, maintain your code, grow your code, modify your code, provide changes, respond to businesses in a modern language, you want that source. And that's what TSRI does. It modernizes the source. It doesn't support kind of the concept of a lift and shift where you're not really doing modernization. You're just taking that code that you had before and getting it in a modern environment. You're not enabling you to grow it in the way you can if you had the code, the source code meaning. Good question. Those were all the questions I had, at least the ones that I got filtered in through what I could respond to. I really appreciate everyone's time. TSRI is available to answer any other questions or to provide additional information. This is only part of what TSRI does, but it's, as I mentioned, a big part. Most of our solutions now are migrating to the cloud. And we're completely dedicated to supporting these efforts, and just follow up and contact our sales and marketing department. And I really appreciate your time. So with that, I'll go ahead and end the recording. Thank you.